So we've been talking about the nutrients, the elements in the environment that are essential for living organs to develop, deliver a healthy life, and reproduce. Some nutrients are quite scarce. They just as much of them in the environment, but fortunately they get recycled. When nutrients are used over and over in the environment, we call that a nutrient cycle. Because of the importance of nutrients and their scarcity, nutrient recycling is one of the most significant ecosystem processes that we'll cover in this course. The three most important nutrient recycles processes that we'll cover in this course. The three most nitrogen cycle, the carbon cycle, and the one we are going to talk about today, the phosphorus cycle. So the phosphorus cycle has been studied a lot by ecologists because, like I said, phosphorus is an important nutrient and is not so abundant. The bottom of the ocean. How the phosphorus get there? Well, let's start with the phosphorus in rocks. The rocks get broken down into the smaller and smaller particles as they weather. The weather rotted slowly by rain and wind over long periods of time. Phosphorus is slowly released as the rocks are broken down, and then it gets spread around into the soil. Once it's in the soil, plants absorb it through their roots. So that's the reason people mine rocks that contain a lot of phosphorus to help agriculture. They mine rock and put the phosphorus into agricultural fertilizers. So humans can play a role in the first fall of phosphorus cycles. They break down rocks and pregnant phosphorus into the soil. By speeding up the rate at which this natural process occurs, you see. Now, after the phosphorus is in the soil, plants grow. They use phosphorus from the soil to grow. And when they die, they decompose, and the phosphorus is recycled back into the soil. Same thing with the animals that eat those plants, or eat other animals that has been eating this plant. We call all of this the round phase of the phosphorus cycle. But a lot of the phosphorus in the soil gets washed away into rivers by rain and melting snow. And the third being another phase of the cycle. Can anyone guess what it is called, Nancy? Well, if the one is called the round phase, then this has to be called the water phase, right? Yes, that's such a difficult point, isn't it? In the normal water phase, the rivers eventually empty into the ocean, and once in the ocean, the fossils get absorbed by water plants like algae. Then fish eat the algae or eat other fish that have eaten those plants. But the water phase is something affected by excessive fertilizers. If not all of the phosphorus gets used by the crops, then a larger amount of phosphorus gets into the rivers. This could cause a rapid growth of water plants in the river, which can lead to the waterways getting clogged with oil in the flow of the water. Several current studies are looking at this effect, and I really do hope we can find a way to deal with this issue before this excessive are adversely affected. Okay? Of course, another way that a human can interrupt the normal process is fishing. The fishing industry helps bring phosphorus back to land. In the normal water phase, the remaining phosphorus makes its way, settles to the bottom of the ocean, and gets mixed into the ocean sediments. But remember, this is a cycle. The phosphorus at the bottom of the ocean has to somehow make its way back to the surface to complete the cycle, to begin the cycle all over again. After millions of years, powerful geological forces like underwater volcanoes lift up frozen sediment to form new land. When an underwater volcano pushes submerged rocks to the surface, a new island is created. Then, over many more years, the phosphorus-rich rocks of the new land begin to erode, and the cycle continues. What about, well, you said that the nitrogen cycle is also an important nutrient cycle, and there is a lot of nitrogen in the atmosphere, so I was wondering, is there a lot of phosphorus in the atmosphere too? Good question, Joe. So you're right to guess that the force can end up in the Earth's atmosphere and can move from the land or from the ocean to the atmosphere and vice versa. However, there's just not a substantial amount of it there, like there is it's a very minimal quantity.